Welcome back to part 2 of the Trig P.2 video. We're going to be dealing with continuing to solve equations. So for this next example, if I'm asking you to solve this equation for x, anytime you have an x squared and an x in your problem, you always want your equation to be equal to 0. That way you can either factor or, in this case, we won't be able to factor, we'll have to use a quadratic formula. So when I subtract 40x, there is no like term over here. So when I put it in order, I want to put the highest exponent first, followed by the second highest, and then followed by the coefficient, the constant I mean, which is just 22. And then I may take the time to go through and try to factor this, but sometimes we're not going to get terms that are that we can actually factor, and so we have to use a quadratic formula instead. So if you don't remember that, the quadratic formula is this. All then divided by 2 times a. And in order for you to be able to figure out what a, b, and c are, remember that the equation, that the general form of the equation is ax squared plus bx plus c equals 0. So that's the form that it has to be in to be able to figure out what a, b, and c are. So I can see what a is. I can see that b would be negative 40 and c would be 22. So let's plug that in. Negative 40. If you want to go ahead and write that as a positive 40 right away, you can. I'm going to go back and change it in just a minute. Plus or minus the square root of negative 40 squared minus 4 times 16 times 22, all divided by 2 times 16. Now when I simplify this, I like to simplify it in a very specific way. I'll reduce this or change it to positive if I can. I'll write down my square root sign. I'll figure out that that's 32, and then I'll type everything that's underneath the square root into my calculator, but not the square root sign. So I'm just going to figure out what negative 40 squared minus 4 times 16 times 22 is. And when I did that, I ended up getting 192. The reason I don't want to type it in all at once is, and this is a good example of it, that this is not a perfect square. So if I was to type it in the calculator with the square root sign, I'd get a decimal. I would try to change that decimal back into a fraction, and it wouldn't work. So what I need to do to be able to make my simplify this answer is I need to think about what is the perfect square that goes into 192. And I know that 64 times 3 is the same as 192. So 64 is the largest perfect square that goes into there. So I can really write this as 8 square roots of 3, because the square root of 64 is 8, and 3 doesn't have a perfect square inside of it. So let's do that. Well, it'd be 40 plus or minus 8 square roots of 3 over 32. So again, I'm thinking about the largest perfect square that divides evenly into 192, and that was 64. And then I look at this and say to myself, okay, all the numbers on the outside of the radical are all divisible by 8. It doesn't matter that 3 is not. I'm not going to reduce that anyways. So when I divide 8 out of all of these, I get 5, 1, leave the square root of 3 alone, and 4. And so that would be the answer to this problem. 5 plus or minus 1 square root of 3 all over 4. When we do problems like that in here, I want you to give me simplified exact answers. Don't type this all into your calculator and get a decimal, so that means no decimals. Unless the problem specifically says round your answer to so many decimal places. So simplified because I was able to reduce these all by 8. Exact value because I left it as a square root of 3 and not as a decimal. Okay, taking a look at our next example. To be able to solve this, I need to factor. And this time I'm going to factor by using the grouping method. So we've got to talk about how we factor using the grouping method. So you use the grouping method when you have 4 terms. So you're going to want to put a set of parentheses around each of the first 2 and the last 2 sets. Notice that the sign with this 8 is inside of that parenthesis, so make sure you group it accordingly. And then you want to pull the greatest common factor out of each set of parentheses. So the greatest common factor between these two would be an x to the third. Now divide an x to the third out of both of those. Okay? And whatever I get in this first set of parentheses, that's my goal for what I should get in the second set of parentheses when I pull the greatest common factor out of here. Okay? If that doesn't match, then you can't use the grouping method to factor this. So looking at these two between here, it's a -8. I specifically am going to use -8 because, again, when I take a -8 out, I get a positive x, and that's what I wanted here. If I took out a positive 8, this would have been a -x. And then finally, I take a -8 out of here, I get a positive 2. Again, I got that match, and that's what I wanted. So once you get that match, write it down once. And then really what's happening is this is being multiplied by both of these, and this is being multiplied by both of these, so I can put what was out in front in its own set of parentheses. And if I was to take the time to FOIL that, I should get all the way back to that. So that's how I can check to see if I factored it correctly. But this would be the factored form of this problem. And now, since it's equal to 0, set both parts individually equal to 0. One thing we need to discuss is when you are dealing with solving polynomials, in this case a degree 4 polynomial, that tells you the number of zeros that you should have. So I should have 4 answers when I'm all done. I won't always get that, but most of the time I should get 4 answers. Okay? So looking at this, I'm going to get 1 answer by subtracting 2. So I end up with a -2 as an answer. Over here, I'm going to add 8. And I get x to the third equals 8. Get rid of the third power by taking the third root. And then remember the third root of 8 is 2. It's 2, 2, and 2. And so that really gives me 3 answers right here, even though I'm only going to write it down once as a 2, because I wouldn't have to write it down x equals 2, x equals 2, and x equals 2. They're all the same answers. So I only have to write it down once, and then recognize that my other answer was a -2. So I get 3 from here, and then 4 altogether, even though it only appears that I have 2 answers. And that's why I write up here the word should, because you're not always going to get whatever that number is, but you should. And I really do for this one, it just doesn't appear that way. Dealing with the next problem, when you're dealing with trying to get rid of radicals that are other than square roots, the first goal is to, or the first rule is to isolate the radical. So that means get it alone on one side. So I've got to get rid of this -5 because it is not underneath the radical. So I'll move it over by adding. So now notice that when I say isolate the radical, that's the only thing on the left-hand side of the equal sign. So it is isolated. Now you can remove the index, or the radical, by raising it to the index power. So if the index is 3, cube this side. And whatever you do to one side, you must do to the other. So by cubing it, you cancel out the third root and the third power. So those will both cancel out, and you'll be left with the 3x plus the 1. And over here, 5 to the third power is 125. And now we can just move everything away from the x. Move the 1 away, move the 3 away by dividing. And when I divide by 3, I end up getting x to be equal to, I can't reduce that fraction at all, so 124 over 3. Again, if I take the time to plug it back in here, I should be able to check it to see if it works. And I would find that that would give me the correct solution. So again, when you're working with getting rid of square roots, cube roots, fourth roots, you have to do this first. You have to isolate the radical before you can get rid of it. Okay, now we're going to deal with radical exponents, or I like to call them fractional exponents, because that's really what it is, a fraction that's an exponent. Again, you want to isolate the term that is being raised to the power. So if I isolate this first, that means that I want to make sure that that is the only thing on the left-hand side of the problem. And for this example, that already is done for me. So the way I get rid of a fractional exponent is I raise it to the reciprocal power. So if the power is 3/2, I raise it to the 2/3. And what I do to one side, I must do to the other side. And I realize that that's hard to see. But what will happen by raising it to the 2/3 is that the rule is I multiply these together. 3/2 times 2/3 makes 1, so they essentially cancel each other out. I'm just left with an x squared minus 5. Over here, when I do this, 27 raised to the 2/3 gives me 9. I can use my calculator to get that, or I can take the third root of 27 and then square that answer. So I write this as the index, and I write this as the exponent with it. So the index was 3, the exponent is 2. I know the third root of 27 is 3, 3 squared is 9. So you can either use the calculator to help you get that, or you can manually figure it out. And so to solve this, you'd move over the 5. Again, because my highest exponent was a 2, I know that I should get 2 answers. And so when I do this, I want to remember that I should get a plus or a minus. And since 14 doesn't have a perfect square inside of it, I'm going to leave it as plus or minus 14. Remember, I want to take the time to go back, plug them in, and check to see that they both work. And again, I would find that they both do work. Last type of problem we're going to deal with are absolute value equations. So again, you want to isolate, in this case, the absolute value bars. In my problem here, I don't have anything going with it, but if I had like a minus 7 here first, I'd want to add 7 to both sides before I started my problem. In this case, they're already isolated for me, so I don't have to do that. So when you have absolute value problems, you need to write 2 equations. So here's how you do that. I like to draw myself 2 little bars here. First, you'll take the side that has the absolute value bars on it and you get rid of them. So you write it exactly like it is and you set it equal to whatever it was equal to. And then we'll go through and we'll solve this. Then, the second time you do it, you still get rid of the absolute value bars, so that doesn't change. But now you set it equal to the negative of the other side. And now these are the 2 equations that I have to solve. So I'm going to move everything over to one side of my problem so that I can factor it. So x squared plus 3x minus 18 equals 0. And I'm going to ask myself what multiplies to be negative 18 and adds to be 3. And I know that that's got to be a 6 and 3 where the 3 is negative. And then when I set these individually equal to 0, I'd end up getting a negative 6 and a positive 3. Then, solving this one, I want to use the distributive property. And then move everything over again. So I'll add 3x. This time I'll add 18. And I will get x squared plus 9x plus 18 equals 0. And I'd want to now ask myself what multiplies to be 18 and adds to be 9. So this time it'd be a positive 6 and a positive 3. And so then I'd end up getting x to be equal to a negative 6 and x to be equal to a negative 3. Now before I actually circle these, I would want to check to make sure that they work, especially with the absolute value problems. Sometimes you'll find that you're going to get extraneous solutions. Again, it's not something that you need to actually write down, but I will show you how to check one of them, and then I want you to go back and check the rest of them to make sure that they work. So if I'm going to check a negative 6, I'm going to do negative 6 squared plus 6 times negative 6, and then I'll take the absolute value of that. So 36 minus 36 would be 0. Absolute value of 0 is 0. Over here, I would do 3 times negative 6 plus 18. So I get negative 18 plus 18, which is 0. So I can circle that and say that that one works. I'd want to go through and do the same for all of these. When I plug a 3 in there, I already know that the negative 6 worked, so I don't really have to circle it again, but I will just to show that that is a correct solution. And I already tested the negative 3 and the positive 3, and they will also work. If you find that you get an answer that doesn't work, just cross it off lightly, like for example like that, even though this one does work. I don't want to cross it off, but that was just to show you as an example. If you test it and it doesn't check out to give you a correct solution, then just cross it off. Don't erase it, don't scribble it out so I can't read it, just cross it off lightly so I know you checked it and it does not work, but you did correctly solve the equation to get that as a result.